Okay, so this is the key to section 14.1 part B, and so you're giving some rational expressions, and you're asked to simplify each rational expression. Now remember, the first step to simplifying a rational expression is to factor. So if you look at the first one, in the numerator, x minus 2, the GCF is 1, and it's just a linear binomial, so there's nothing you can do with regards to factoring the numerator. But in the denominator, that is the difference of two squares, and so we're going to factor the difference of two squares for x squared minus 2 as, all right, so the numerator, there's nothing you can do with that in terms of factoring. The denominator, that's going to be x minus 2 times x plus 2. All right, so once you factor, the next step is to reduce. So you look at the numerator. The only factor that you see in the numerator is x minus 2. And so you want to look at the denominator and see if you see a factor of x minus 2, and you do, right here. Now, remember that 3 divided by 3 is 1. So these two factors are the same, and so when you divide them out like this, 3 into 3 is 1, 3 into 3 is 1, you get 1. So when you look at this, if I cover this part up right here, you have x minus 2 divided by itself. Well, x minus 2 divided by itself is 1. But when we reduce rational expressions, what we do is we say x minus 2 into x minus 2 is 1, x minus 2 into x minus 2 is 1. Just like we would do here, 3 into 3 is 1, 3 into 3 is 1, and 1 divided by 1 is 1. All right, so in those places you put factors of 1. So you just don't cross these out like that. You got to put factors of 1. And so the answer then becomes 1 divided by, and the 1 times x plus 2. This factor x plus 2 is just x plus 2. So you have 1 divided by x plus 2. All right, number 2. So number 2, in the numerator, is also the difference of two squares. And so I'm going to factor this as x minus 3 times x plus 3. So the first step is to factor. And if you look at the denominator, I can factor that as well. So I can factor that as x plus 3 times x plus 3. And so the next step is to reduce, to divide out your any common factors. So if you look at the numerator, there are two factors. The first one is x minus 3, and the second one is x plus 3. So if you look at x minus 3, will this factor reduce with any factors in the denominator? So you have an x minus 3. Is there an x minus 3 occurring as a factor in the denominator? The answer is no. So if you look at the next factor, x plus 3, is there a factor of x plus 3 occurring in the denominator? The answer is yes. In fact, there are two of them. But since there's only one here, you can only use one of these. And so I'm just going to use this one here. And so x plus 3 divided by x plus 3 is 1. X plus 3 divided by x plus 3 is 1. And so then you have x minus 3 times 1, which is x minus 3. And then x plus 3 times 1, which is x plus 3. And so you get x minus 3 divided by x plus 3. The next one. So number 3, the numerator, again, the GCF here is 5v, so I can factor out a 5v. And so I end up with 5v times v is 5v squared minus, and then 5v times a negative 1 is a negative 5v. The denominator, we'll leave it as 1 minus v for right now. And so if you look at the numerator, there are three factors in the numerator. There's a factor of 5, there's a factor of v, and there's a factor of v minus 1. And then the factor that I see in the denominator is 1 minus v. So in regards to the first factor 5, there's no factor in the denominator that 5 can reduce with. And the same thing for v. So remember, this is a factor of v. This is not a factor of v. This is a factor of 1 minus v. So I cannot reduce these v's right here. Now the next factor, v minus 1, I don't see a v minus 1 exactly written like that in the denominator, but I do notice that v minus 1 and 1 minus v are opposites of each other. So these two factors are opposites. So remember, when we talk about opposites, so it's like negative 3 divided by 3. So negative 3 and 3 are opposites. So when I look at their quotient, when I divide them, I'm going to get negative 1. So when you divide opposites, you end up with a quotient of -1. But remember, in terms of reducing, we'd say 3 into 3 is 1, 3 into -3 is -1. And so -1 divided by 1 is -1. So when we reduce opposites here, the way we're going to do this, see, and this is just preferential in terms of this class, but we tend to let the bottom factor end up being 1 and the factor in the numerator be -1. So in other words, when I divide these out, now remember, don't put ones like this because they're not the same factor. They're opposites. So make this a 1, this a -1. Alright, just like this. Alright, so then I get 5 times v times -1, which is -5v. And then my denominator is just 1. But again, don't leave your answer like this because you need to remember that any numerator divided by 1 is just what's in the numerator. So that's just -5v. So that's what goes here, -5v. Number 4, I have a linear factor that's in the denominator, in the numerator. So the GCF here is also 1. So I'm going to leave it like this for right now. All right, there's nothing much I can do there. But in the denominator, I can factor this as, let's see, x minus 2 times x plus 6. So I need a positive 4x, and so the outer is a positive 6x, the inner is a negative 2x. When I add them up, I do get a positive 4x. And then -2 times positive 6 is -12. All right. Now, again, 2 minus x is the factor that's in the numerator. I don't see it listed exactly like that in the denominator, but I do notice that 2 minus x and x minus 2 are opposites. So those factors are opposites. So remember, the opposite of 2 minus x, all you're doing is just changing the signs. The opposite of a positive 2 is a -2, and the opposite of a negative x is a positive x. All right, so again, when I divide them out, when I reduce those, I get 1 here, -1 here, and so I get an answer of -1 divided by, and then 1 times x plus 6 is x plus 6. Okay, and then number 5, when I factor that numerator, the GCF is 1, so I'm going to factor as 2 binomials now. So xx, 5 and 2 will work, and the 5 would be negative and the 2 would be positive. And always check, the outer is a positive 2x, and the inner is a negative 5x. I'm going to add them up, I get a negative 3x, and then a negative 5 times positive 2 is a negative 10. And the denominator, that's going to end up factoring as x plus 4 times x plus 2. So the outer is 2x, the inner is 4x. I'm going to add them up, I get 6x, and 4 times 2 is 8. Alright, so let's reduce our common factors. And so if you notice, the only common factor you can reduce is the x plus 2's. So, and those are exactly the same. So when I reduce those, I end up with factors of 1's that are left. And so x minus 5 times 1 is x minus 5. And x plus 4 times 1 is x plus 4. So that goes here. Alright, so that should, there's nothing in the back, so that should take care of this key to worksheet 14.1, section 14.1, part B.